So, okay, we continue. So, the question is a chlorine consisting of two isotopes of mass 35, that is chlorine containing of two isotopes of mass 35 and 37 in the ratio 3 to 1 has an atomic mass of 35.5. Then calculate the relative abundance of the isotope of mass 37. Calculate the relative abundance of chlorine 37. So we already know what isotopes are. They are atoms of the same element. Of course, having the same atomic number but different mass numbers. So what they are saying is that chlorine comprises of two isotopes, one with a mass of 35, another one with a mass of 37. And the ratio of the abundance is 3 to 1, which means the chlorine with chlorine 35 is more abundant. So it's like it's 3 more times more abundant than chlorine 37. So that is what the ratio implies. And that the relative atomic mass of the chlorine is 35.5. So it is neither this nor this, but it's placed in between the two, but closer to this than this because this is more abundant. So this is relative atomic mass. So in some questions, they will give us the percentage abundance of each of the isotopes and be asked to calculate it, the relative atomic mass. But in this question, we're given the relative atomic mass, the ratio, and they are now asked to find the percentage abundance. You understand? The relative abundance in percentage. So, but it has been given a ratio. So there is not much calculation to do here. But we have to do that for chlorine 37, the one that has mass number of 37, which means we are coming for this. And this is the ratio. So I think all we have to do here is what do I call it? Is to take the total ratio. The total ratio is what 3 plus 1 is equals to 4. So the abundance or the percentage abundance of chlorine 37 is equals to 1 over 4. You understand? That's all. They multiply by 100. This is as simple as that. And this will give us 25%. So I don't think it is going to be more than that. So it shouldn't be more than that. You understand? Because on a good day, 3 all over 4 of 35 plus 1 over 4 of 37 is what gives rise to 35.5. So if you want to check it, we check. Let's say, my calculator, 35 multiplied by 3 divided by 4 gives me 26.25. Then plus 37 by 4, 27 by 4 gives me 9.25. Then adding the 2, 26.25 will give 35.55. So all you just need to do is to divide this by the total ratio, multiply by 100, and it means 55% is the abundance of chlorine 37. So that of chlorine 35 will definitely be 75%. But the question is for this, so 25% is the answer. And we have it in the option as option D. So the next question says an electron can be added to a halogen atom to form a halide ion An electron can be added to a halogen atom. Hmm? A halogen atom. So an electron can be added to it to form a halide ion. Understand? To form a halide ion with A says 8 valence electrons, 7 valence electrons, 2 valence electrons, 3 valence electrons. So a halogen is a group 7 element, and as a result, it has 7 electrons in its outer shell. Understand? It has 7 electrons in its outer shell as a halogen, as a group 7 element. So every group 7 element is expected to, by the name, has 7 electrons in its large shell. So if an electron is now added, of course, it forms, when you add an electron or you remove an electron, the atom becomes charged. It was neutral before the addition or removal of electron, but once electron is added or removed, it becomes charged. So if electron is added, it becomes negatively charged. If it is removed, it becomes positively charged. So when an electron is added to this, then what becomes of the valence shell? The valence shell is the large shell that contains the same electron. So when one electron is added, then by adding an electrons, it gives it's a valence shell with 8 electrons. It gives a valence shell with 8 electrons. So it can be 7, it can still be 7 or any other number like they are mentioning. They say 8 valence electrons, 7 valence electrons, 2 valence electrons, 3 valence electrons. So the answer should be 8 valence electrons. That should be the answer. Okay, that's so the halide ion is the ion that resulted because this is the halide. Let's represent the halide with S. Now by adding an electron, they form a halide ion, S negative. So if it is chlorine, it will be chloride ion. If it is fluorine, it will be fluoride ion. If it is bromine, it will be bromide ion. If it's iodine, it will be iodide ion. So the answer is 8 valence electron. Then the next question is it gives. I think if I say it well, it's 228 Ra radium. I think down there is not very clear, but I think it's 86. Then giving radon of 24, I think, and X. Then with what? An alpha particle. So this is a kind of radioactive decay, or an alpha by alpha. This is an alpha decay in a radioactivity or nuclear chemistry. So you know upon that's what we call a radioactive element or a radioactive substance. So this substance has the tendency to disintegrate or to undergo what we call radioactive decay. It disintegrates and then in the course of that emits some radiations and as well as energy. So there are three of such radiation that can be emitted. You have the alpha ray, the beta, and the gamma. So the alpha is actually a helium particle. So the alpha particle is a helium particle with this number of protons and this mass number. Then a beta particle is just an electron with a negative one charge and zero mass. A gamma radiation, a gamma ray. These two are particles, while this is just it's just an electromagnetic ray. So this is a ray, and it is not a particle, so it's just a ray. So in radioactive decay, these radiations are given. So if it is a decay by alpha, if it's an alpha decay, then we expect emission of alpha particle, that is a helium nucleus. Then if it's by beta decay, then we expect an emission of a beta particle, which is an electron. So in writing the equation, if a nucleus undergoes an alpha decay, then we expect that the atomic number, the resulting element, which we call the daughter, this is the parent nucleus. The resulting nucleus, which is the daughter nucleus, will have an atomic number 2 less than the parent, because a helium particle, an alpha particle is a helium particle. So, and in the balancing of the equation, there must be balance in the number of the atomic number, the number of protons, and then the mass number. They must be balanced, and also the charges. So if that is the case, if this is 86, then we must have a total of 86 here. An alpha particle, like I said, is a helium nucleus. So already, if this is going to be 2, then that means this will be 84. So that 84 plus 2 will give you 86. Then and then for the mass number, of course, it is going to be 4 less of what you had here. So which means in this case, the equation is this: 22886 goes to radon. So if radon 84, if an alpha particle is written as a helium nucleus, then this should be 28. 228 minus 4 should give 224. So which means our S is actually equals to 224. So that's how you balance a radioactive equation, a nuclear equation. So what you need to know is that an alpha particle is a helium nucleus with proton number of 2 and this. So had it been it was a beta emission, then it means this will be 85. We have to increase by 1. So this would have been 87. That 87 minus 1 would still give 86. And this would have remained the same with the 228. So in alpha particle, the mass number of the daughter nucleus remains the same with that of the parent, while the proton number will be what? 1 more than the parent. That is for a beta decay. If it is a gamma ray, it does not change anything. So it's just a radiation. This is not a particle. So I think that is clear. So and this may be where we are going to stop this. So let me see my time. Okay. So I have to stop here. Then continue from here in the next class. Thank you.